Hey class, welcome back, and we are taking a look at the last couple of subsections of Unit C. This is a long unit, but it's an important one for getting us going here in stats. And so this is looking at something called the empirical rules of thumb, and it has to do with the normal distribution. So let me just read this paragraph here. It says, an important statistical principle which we'll analyze in some detail in a succeeding unit, particularly Unit N, is that many distributions of numbers are bell-shaped or normally distributed. For example, consider the heights of male students in a typical class. Most students will have heights close to the class averages, let's say 5'10". We will count fewer and fewer males as higher and subsequently lower heights are considered, until there's very few males which are over, say, 6'5", and very few males which are under, say, 5'3". And a similar phenomena may exist for marks on a midterm exam. So a lot of things, heights and weights and IQs and things like that are normally distributed. And so we've got some what we call empirical rules of thumb that have to do with the normal distribution, but we'll just call them empirical rules at this point. And they're the relationship between the mean, mu, and the standard deviation, sigma. Or if you're dealing with a sample, it could be an X bar and an S. So that works as well. And there's three rules here, and that is that the mean plus and minus one standard deviation, so mu minus sigma, and mu plus sigma encompasses about 68.3% of observations. Now, when I say about 68.3%, what that means is that if the data are perfectly normally distributed, and then you would find that that proportion would hold. When we take a look, for instance, at IQs of people, where there's an average of 100, you'll find that they're normally distributed. And so 68.3% actually falls within one standard deviation on either side of the mean. The standard deviation is about 15. So about a little over 2/3 of the population have IQs between 85 and 115. And then the mean plus or minus 2 standard deviations encompasses about 95.4% of observations. So if we're talking IQs, if we went another 15 units, if a standard deviation is 15, then let's see, 85 minus 15 is 70, and then going up the other way to 130, that would be 2 times 15, you should have 95% of the population have IQs between 70 and 130. And then the mean plus or minus 3 standard deviations encompasses almost everybody, 99.7%. So with IQs then, that would be anywhere from 15 from 70 is 55 to 145. So you've got almost 100% of people. Now, you do have people that are smarter than that, and also people who are more challenged in terms of their IQ below that number. But that will encompass just about everybody. And so this is known as the 3 sigma rule. The 3 sigma rule means that just about everybody is within 3 standard deviations of the mean when you're dealing with a normal distribution, of which a lot of stuff is normally distributed. Let's take a look at the ages of the 50 people. Are they approximately normally distributed? And then I'm going to leave number 48 here for you to do for homework. Now, let's take a look then at the ages of the 50 people here. And so this is, we're going to take a look at the mean plus sigma. And let's see where we get those numbers from. So the mean is equal to 70. And then, so this is going to be, plus and minus. It's going to be mu plus sigma and mu minus sigma. And the standard deviation turned out to be 17.44. Where did we see those? This was from page C3, so where we calculated the mean, and then C23, is it? Where we calculated the standard deviation. Let's just go back here to 23. Is that the right page? Yeah, I guess it is. Yeah, 17.44. So now that will leave us with, let's see, 70 minus 17.44 is 52.56. And then the upper bound would be 70 plus 17.44, which would be 87.44. And the question is, how many values fall in there? Well, let's go back, actually. I think, where was the last place that we actually saw that data? How about right there, back on page C23. So here's the data right here. And we had a mean of 70, so I'm just going to put a little mu here. And then, let's see, that lower bound there was 52.56, so that would be right in here. So that would be mu minus sigma, and then it was 87.44, so this is mu plus sigma. And then we just simply count the number of values. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each row. So we have 1, 2, 3, 4, 5, 15, 25, 35, 36, 37, 38 values fall from here, from this star to this star, with mu being in the middle there. So there's 38 values there. So let's go back to where we were. So we have 38 out of 50 values is equal to 76%. And it should be it should be 68.3%. So that's a little high. All right, let's go to mu plus or minus 2 standard deviations. So that would be 70 plus or minus 2 times 17.44. So we're just going to subtract 17.44 from 52.56. That gives us 35.12. And then 87.44, we're going to add 17.44, and that will give us 104.88. Let's see how many values fall in there. So we're going to go back a few pages again. And let's just change this to a different color here. Let's use maybe red. And so that was, what was that, 34? 35.12, so that would be right here. This would be mu minus 2 standard deviations. And then we're looking at 104 right in here, so mu plus 2 standard deviations. 2 standard deviations. And if you count them up, you'll see that it includes all of them except those first 3. And so that's 47 out of the 50. So we end up with 47 out of 50, which is 94%. And according to our empirical rules, it should be 95.4%. That's pretty close. You can't get it much better than that. I suppose if you had 48 values, it'd be a little closer. But that's within one value there. So that's looking pretty good. And then the last one here then is let me change colors again, mu plus or minus 3 standard deviations. So that would be 70 plus or minus 3 times 17.44. And so that would be 35 minus another 17.44 gives you 17.68 as lower bound. And then a higher bound would be 122.32. And let's see how many values fall in there. So we've got right in here. So this would be mu minus 3 standard deviations. And then we've got the upper bound is still the same here, mu plus 3 standard deviations. And so that is just about everybody. That is everybody except that first number, which is 14. And so 49 out of 50 of the observations fall there. So we've got 49 out of 50 is equal to 98%. And according to our empirical rules, it should be 99.7%, virtually all of them. So the question is, are these normally distributed? And the thing is that with stats at this point in the course here, we don't really know how close is close. And there will be ways of checking that later, and even further when we get into Business 307. So this case, it's really just a call. What I want you to do is to be able to do these calculations and tell me what percentage actually do fall within 1, 2, or 3 standard deviations and what they should be. And these numbers of what they should be are, these ones here are hard, fast rules. Those are 3 numbers that you just need to memorize: 68.3%, 95.4%, and 99.7%. So I would probably look at this and say, well, this 76% is a little high here. And these two are pretty close. They're not too bad here. So I would tend to say that it's there's some question as to whether it's normal or not here, because that first one is just a little too high there. You've got too many bunched up towards the middle there. So for the next one here, I'd like you to take a look at this. Just before we get into that one, I would like you to take a quick look here at what page is that again? Somewhere around here on the normal distribution. And here's the midterm marks of the 50 people. So these are the ones that we're actually looking at in the homework problem here. And we'll be analyzing this, but this is what the distribution looks like. And so on the left-hand side here, you'll see all of the values right here of x, 34 up to 90. You've seen those numbers before. And then this is how they look in terms of 1, 2, and 3 standard deviations. So these are the numbers that we're looking at. Now yours will be slightly different because we're using the grouped numbers, the group mean and the grouped, the sample mean and the sample standard deviation, because that's what we calculated last, was the sample standard deviation. So they'll be slightly different, but they should be pretty close to those. And what you'll find actually is that these data are almost perfectly normally distributed. So that's a hint in terms of what you should be getting here. And that was on page N5 if you want to take a look at that. But that's what I would like you to do for homework is this guy right here. And then we'll get into the last part, which is coefficient of variation in the next and last